In this lesson, we shall focus on Mathematics 1B, Math 141 Tutorial 9, Parametric Curves, and we want to find the arc length. Find the arc length of the curve over the stated interval, and we are able to see that this is the curve defined by x equals 2 to the power t in brackets or e to the power 2t in brackets sine t plus cosine t, y equals e to the power 2t in brackets sine t minus cosine t. And now at this point, we want to find the arc length. Now to find the arc length of this particular curve, because we need to find like the arc length of the curve. So first we need to be able to find the derivatives. So we're going to find the dx dt. The derivative of the x dt is going to be 2e to the power 2t. The sine of t cosine t plus e to the power 2t cosine t minus the sine of t. Right. So now you have dy dt 2e to the power 2t, the sine of t minus cosine t plus e to the power 2t. Then by the product rule, the derivative of the sine becomes cosine t plus the sine of t. So this therefore becomes actually the derivative. But now, what does this derivative simplify to? Can this be actually simplified any further? Like you have this one, 2e to the power 2t sine t. Now the cosine is going to be that. Yes. The dx dt is actually equal to, at this point, if you consider the e to the power 2t, the 2e to the power 2t minus the sine of that, so that is going to be e to the power 2t. For instance, this is going to be sine t, because there are two of the e to the power 2t, but you minus one of the e to the power 2t, then is sine e to the power 2t. And then now there is also this one here, 2 of the e to the power 2t for the cosine plus e to the power 2t. So it's going to give us 3 right of the cosine of t.
Sorry,
Yes, please.
yes, I'm lost.
Where? Okay. Let us restart. Let us begin again. We're just finding the derivatives of the two functions. So we're using the product rule. So now, given a product of functions, you need to be able to find the derivative of the product, and we use the product rule first. Let us recap perhaps on the product rule. The product rule is a method we use to find the derivative of a product. If we are looking at y equals f times g, then y primed, the derivative becomes f primed times g plus f times g primed. And this is called the product rule. So now dx dt is 2e to the power 2t. Then you have the sine of t plus cosine t. E to the power 2t, then the derivative of that is cosine t minus the sine of t. Simultaneously, you have dy dt, which is 2e to the power 2t. The sine of t minus cosine t plus e to the power 2t e to the power 2t, the derivative of the sine becomes cosine t plus the sine of t. So now, at this point, this is the product rule, because the derivative of e to the power 2t, it's 2 e to the power 2t by the chain rule. The chain rule says you differentiate the 2t and the derivative is 2, then you have e to the power 2t. You leave the sine t plus cosine t constant, then you have e to the power 2t find the derivative of the interior. The derivative of the sine becomes the cosine of t minus the derivative of the cosine, it becomes minus the sine of t. Simultaneously, you need to find the dy dt. So derivative of the e to the power 2t, it's 2 e to the power 2t. So by the chain rule, we found the derivative of e to the power 2t. Then we keep the sine t minus cosine t constant. Then e to the power 2t, the derivative of the sine becomes the cosine. The derivative of the cosine becomes minus sine. But yeah, minus minus becomes plus. Now, we need to just simplify this a little bit because we'll have to square these things here. So they are wrong. So let us perform some algebraic simplification of this. So now, if we're to multiply this and add like terms, there is 2 e to the power 2t sine t, and then there is minus e to the power 2t sine t, and this is going to actually give us what? It's going to give us e to the power 2t sine t. So this e to the 2t, then it's going to give us the sine of t. Let's look at 2e to the power 2t cosine t, and then plus that. So it is actually 3 cosine t. Right, so we have dy dt. 2e to the power 2t sine t and plus sine of t, then this e to the power 2t, then we have 3 sine t. Then we have 2e to the power 2t minus cosine t plus e to the power 2t cosine t, then the 2 is negative, so it's going to give us the negative of the cosine of t, like this. Okay, now this is exactly what we have here. Now, at this point, we have found the derivatives that we need. So now, what exactly do we need to do? We need to find the d squared, the dx dt squared plus the dy dt all squared. Okay, to find the arc length, we need to find the sum of the squares. Okay, we need to simplify this a little bit. It looks a bit big. Right, so we have e to the power 2t, then you have the sine of t plus 3 cosine t. And then you have squared plus e to the power 2t, then you have 3 sine t minus cosine t. And then you square this. Okay, so what does this simplify to? Obviously it's a bit it's a bit lengthy, but now we need to actually be in a position to multiply these things out. So if you look very carefully, then we would have to we can take out the common factor, and the common factor is e to the power 4t. E to the power 4t is going to be e to the power 2t, and there's also e to the power 2t, take out the common factor. And then now you square sine t plus 3 cosine t, you square it. What will it give us? Okay. Okay, good. Yeah, the reason for squaring is because we're going to use the arc length. The arc length says we need to square the derivatives. So that is the reason behind the squaring. But the squaring is that the arc length is the integral from a to b of the square root of dx dt squared plus dy dt squared dt. So this is what we need to do. This is exactly what we need to do. So that now you have the sine of t. So now when you have the sine of t, okay, this is the formula. So we need to square. We need dx dt squared plus dy dt squared. Now at this point, you'd have this. So what is the sine of t, cosine t, and then squared? Okay. Yes, sorry, it has everything to do with the arc length formula. Yeah, so it does not quite relate to the circle formula. It does not quite relate to the circle formula, but it's everything to do with the arc length formula. Okay, right. So now at this point, you have the sine. You have sine t plus 3 cosine t square root. So that is going to become the sine squared of t, 6 sine t, cosine t, 9 cosine squared t. Okay. So you then need to have also the next thing we're going to have. So it's going to be plus. Then we have this one, which is 9 sine squared t. And then we have this minus 6, the sine of t, cosine t, plus cosine squared t. Okay, the squaring gives us this, but let us check if we can find any like terms. This and that do cancel out. And then you have sine squared t plus cosine squared t. So at this point, what is very clear is that actually our dx dt squared dy dt squared is the dx dt, which is e to the power 40. And then you have sine squared t plus cosine squared t. Right, so with sine squared t plus cosine squared t plus 9 cosine squared t, 9 cosine squared t plus 9 sine squared t. And this means that dx dt squared plus, so we can continue here and write e to the 4t. Sine squared t plus cosine squared t is a 1. And this one is actually exactly plus 9 in brackets cosine squared t plus sine squared t. Write that at the bottom. Write that at the bottom. And then you have dy dt squared e to the 4t. Now the sine squared plus cosine squared is 1, giving us 9 cosine squared t plus sine squared t. E to the 4t, 1 plus 9, which is 10 e to the 4t. Right, which is actually exactly 10 e to the 4t. Okay, we've got 10 e to the 4t, then that is the sum of these things. So at this point, the sum of the squares. But the arc length is the integral from a to b of the square root of dx dt squared plus dy dt squared dt. The integral from -2 to 2 Okay. 10 e to the 4t. Okay, so yeah. So let us find this integral here. So this will be the square root of 10 because square root of 10 is a constant. Then you have the integral from minus 2 to 2. The square root of e to the 4t is e to the 2t dt. Square root of 10, the integral of e to the 2t would be e to the 2t out of 2. Then you integrate from negative 2 to 2 because it's from negative 2 to 2 here, which is therefore the integral of the square root of 10 over 2 e to the 2t minus e to the 2 minus 2, which is out of 2, which is e to the 4 minus e to the minus 4, which is this, which is exactly the answer they gave us. So which means to find the arc length of the curve over the stated interval, we found the answer. The answer is that. Not only that, the answer is that, but it is arc length, and length is measured in units. So you could then say it is exactly that units, and that concludes the answer to the problem. So actually, at this point, and at this rate, we have succeeded in solving this particular problem here. We have succeeded in solving this particular problem here. We recap on this and make sure we understand what we've done. To start with, we actually focused on the C. And in the 3C solution, we had to find the arc length. And we note that the formula for the arc length is L equals the integral from A to B of the square root of dx dt squared plus dy dt squared dt. So we need to find dx dt. What is the derivative of dx dt? All right, so we continue. Okay. So now, now we need to discuss this. So the dx dt, the derivative of this one is a product. So in mathematics, when you're given a product, we use the product rule. What is the product rule? It says that if you have f and g as a part of functions, and the derivative is actually the derivative of f first, so you find derivative of the f function, and then plus f times the derivative of the function g. This is called the product rule. In this case, and at this rate, we'd have to find the derivative of e to the power 2t, which is 2e to the power 2t. Then you have sine t plus cosine t. The next thing is you have the e to the power 2t. The derivative of sine t is cosine t. The derivative of cosine t is minus sine t. dy dt, the derivative of e to the power 2t is 2e to the power 2t. And then you actually keep the sine t minus cosine t constant. And then now we have e to the power 2t. The derivative of the sine t is cosine t. The derivative of minus cosine t is the sine of t, which means that e to the power 2t would therefore give us the sine t plus 3 cosine t. So here we add like terms, and adding like terms after distribution, we get this one. For dy dt, if you just multiply out here and add like terms, this is what we get. Okay, and now because I saw that this is long, the dx dt has several terms, and dy dt has several terms. So I decided, okay, let us do everything before we put this result into the arc length formula. So the dx dt plus dy dt, the dx dt squared plus the dy dt squared. Right. Right, so we have the following. Right, we have the following. We have exactly the following. So, which is the dx dt? Right, okay, we take a look. And we square the dx dt and we square the dy dt. And so we squared these in a very cunning and clever way. I mean, there are several ways of squaring this, but e to the 2t squared is e to the 4t, and then the e to the 2t squared is e to the 4t. So e to the 4t is going to be a common factor from the two expressions, giving us a sine squared and then 6 sine t cosine t, and then the 9 cosine squared t. Then we have the 9 sine squared t minus 6 sine t cosine t plus cosine squared t. Then now at this pointer, you'd have the sine squared plus cosine squared t, which is what we have. But simultaneously, we also have the following. We also have the following. We also have 9 cosine squared t plus 9 sine squared t. 9 cosine squared t plus 9 sine squared t. 9 cosine squared t plus 9 sine squared t. And this is cosine squared t plus sine squared t, which is exactly a 1. And the 1 plus 9 gives us exactly 10 e to the 4t, which means you have the integral of a to b dx dt squared plus dy dt squared dt, and then the dx dt squared plus dy dt squared gives us 10 e to the 4t, because that's what we got. But we put everything under the square root in the arc length formula. So we put 10 e to the 4t under the square root. So this is what we have. So if that is the case, so we have 10 e to the 4t, right, which is 10 e to the 4t. So now then you have the square root of 10, then the e to the 4t. You take the square root of that, which is e to the 2t. And then the integral of that is e to the 2t out of 2, integrating from -2 to 2. So at this point, it is e to the 2t minus e to the 2 times -2, which is e to the 4 minus e to the -4. So now at this point, this is what we have. This is what we have. Now, this is what we have. Okay, and this is the answer that has been given for 3C. It is the square root of 10 divided by 2 in brackets e to the 4 minus e to the -4. So this is the arc length in 3C. Next, let us continue to practice and look at the next problem. Right, so the next problem is 4. Calculate the length. Yes, calculate the length of one arc of the cycloid parametrized. So, or it is basically an arch So now if you need to calculate the length of one arch of the side load parameterized by this, the answer is 8 units. Okay, the side load is parameterized by this. So you need to calculate just the length of one arch. So x is t minus the trigonometric sine of t, and y becomes 1 minus cosine t. So these are the parametric equations of just a single arch, right? So at this point, we need to do what we know. We need to find the derivative dx dt. One minus cosine t. So dy dt, derivative of this becomes exactly the trigonometric sine of t. So at this point, if we're doing the arc length, we integrate from a to b, and that is the formula. And then we have the dx dt, right? Dx dt squared plus dy dt squared dt. And therefore, we have the integral here from 0 to 2t. The square root of the dx dt, which is 1 minus cosine t squared plus the sine squared of t dt, which is okay here. So it's from the t is from 0 to 2 pi radians. Okay, so this gives us the units. So if you have 0 to 2 pi, so this is what we need to do. So we square everything here. So it's 1
Sorry.
minus, yes, please.
So even if you do the similar approach like you did last time, it's still gonna give you the same answer, right?
Yes.
The way you squared before and
Before
plugging
putting,
it
yes, before
in.
plugging it into under the square root, because I did that because it was too long, that one. I realized that it was necessary to simplify first the everything to be put under the square root. So we could do the same here, but this one I realized that it was not going to be very long under the square root, so we could quickly simplify. Okay, so obviously it will give us the same answer still. So you still have the 0 to 2 pi, then you have the square root of. Now, you have cosine squared t plus sine squared t is 1. Because cosine squared t plus sine squared t is 1, 1 plus 1 gives us 2. Minus 2 cosine t. Obviously this one is a dt. Right, so if it is exactly dt, then we have exactly the following. Yeah, so take note of that. So this is going to be exactly dt. Now, we actually therefore can be able to achieve the following. We have this here. I need to find the integral of this. The question is, what exactly is the integral of this? So you can pull out the square root of 2, the constant, have the integral from 0 to 2 pi radians of the square root of 1 minus cosine t dt. Okay, so we have this. Now the question then is, what exactly becomes the integral of this? What exactly becomes the integral of this? Right. Now, let us reason this. It's a very interesting integral. So what would you then obviously think of this integral as? So you need to look at the right way to deal with this integral by substitution. The question is what substitution is the right one to use in dealing with this one. What is the right way to deal with this particular integral here? Right, so it is very interesting. So now, so you'd have this particular integral. What would this one be? Okay, we use trigonometric identities. Right, we use trigonometric identities because we have knowledge of some trig identities. What exactly do we know? We know that cosine 2x, what is cosine 2x? Is 1 minus 2 sine squared x. So that cosine x, 1 minus 2 the sine squared of x over 2. So, dealing with one arch, so it would mean therefore 2 sine squared of x over 2 is 1 minus cosine x. In other words, 2 sine squared t over 2 radians is 1 minus cosine t. At this rate, we have the square root of 2. We have the square root of 2. And we have the integral from 0 to 2 pi. Whenever we have the square root of 1 minus cosine t, 1 minus cosine t is 2 sine squared t. 2 sine squared t over 2 dt.
Sorry.
Yes, please.
Yes, can you please re-explain that part? I'm so confused. How is cos x equals to that?
Here, okay, cosine 2x. To say cosine 2x is equal to 1 minus 2 sine squared x. Okay, obviously this is a double angle formula. Double angle formula. Okay, in light of the fact that cosine 2x is cosine squared x minus sine squared x, which is 2 cosine squared x minus 1, which is 1 minus 2 sine squared x. So these are 3 formulas that for cosine 2x. We repeat because it's important. Cosine 2x is cosine squared x minus sine squared x. But cosine 2x is also 2 cosine squared x minus 1. But also cosine 2x is 1 minus 2 sine squared x. And therefore, this becomes so important for us. Because these are the double angle formulae for the cosine 2x. So we're going to use the fact that cosine 2x is 1 minus 2 sine squared. Why? Because now when you transform this cosine 2x, it's able to produce 1 minus cosine t. But now we can write this in terms of half angles, because this is 1 minus cosine t, is not 1 minus cosine 2t. So if cosine 2x is 1 minus 2 sine squared x, then what about if it's just cosine x here? Then it was just half of the 2x, because half of 2x is x. So that cosine x, therefore, is half of the x. So this becomes what you call a half angle formula. Right, a half angle formula. Okay, if then we have the half angle formula, and then we have this one top gives you a double angle formula. So at this point, we have 2 sine squared x over 2, which is 1 minus cosine x. Then at this point, what we're then getting is that 2 sine squared t over 2 is 1 minus cosine t. Is 1 minus cosine t. So that whenever you have 1 minus cosine t, what are we getting here? Okay, so whenever you have 1 minus cosine t, it is actually exactly the same as 1 minus cosine t, the square root is actually the same as 2 sine squared t over 2. And let us continue at the bottom here. And this gives us exactly the square root of 2, but there is another square root of 2, and then you have the integral of 0 to 2 pi. And then, if you integrate these, the sine squared, it becomes the modulus. From 0 to 2 pi, it becomes the modulus of the sine of t over 2 dt. The square root of 2 pi, the square root of 2 becomes 2, the integral from 0 to 2 pi of the sine of t over 2 modulus dt. So that in the end, we have the following. The arc length becomes the integral from 0 to 2 pi. You then have square root of 2 pi square root of 2 with the 2 outside. And then we can write it perhaps properly and have the exactly 2, the integral of 0 to 2 pi, the sine of t over 2 modulus with respect to t. If the modulus is computed, then you would have exactly the following. So if you integrate, but you need to integrate, you need to take one of these, obviously, and then the length of one arch. Okay, good. But we reason together. Between 0 and 2 pi, what happens to the sine of pi over of t over 2? Let us look at these part by part, because you have what you call the cast diagram. In this cast diagram, it's going to give us 0, pi over 2 radians, pi, and then 3 pi over 2 radians, and then 2 pi radians. Between 0 and 2 pi, the sign is going to be positive in these two quadrants, but now this one obviously is it's the half. It's a half angle formula, so it's going to be an interesting one to actually obviously analyze. But for instance, from 0, if you put 0 here, it's going to be 0 out of 2. If you put 2 pi, it's going to be the sine of pi, because it's going to be 2 pi out of pi. So up to the sine of pi, up to the 2 pi, then the sine itself becomes exactly a positive there. Okay. So that then in the end, you have the integral Right, and if you have the integral 0 to 2 pi, for the parts where it's going to be positive, let's analyze this. And then now, you then have the resulting trigonometric sine of t over 2 dt. And therefore, what would the integral of this be? So it's 1 over 1/2. Then the integral of the sine becomes exactly what? Negative cosine of t over 2. And then 2 pi. So now it's 4. Minus 4, which is the cosine of 2 pi out of 2, minus the cosine of 0 out of 2, which is cosine pi minus cosine 0. What is cosine pi? It's minus 1, minus 2, and this is minus 1, minus 2, which is a minus 1, minus 1, minus 2 times minus 4 gives us exactly 8 units. On these 8 units, therefore, it's the answer we want, and this is the length of one arch of the cycloid parametrized by exactly those equations. It's one of the length of one arch. The length of one arch of the cycloid parametrized by those particular equations there. So look at that and think about it, but think about it very carefully because we started off at the beginning. So we started off here. Right, we started off here for number 4. As usual, we first find the dx dt and also the dy dt. And after having found those particular answers, we then are able to find the dx dt and dy dt, and then we put everything under the arc length formula. The arc length itself is obviously the integral from a to b, and then you have the square root of the dx dt squared plus dy dt squared dt. You integrate from 0 to 2 pi, the square root of 1 minus cosine t squared plus the sine squared of t dt, and we have that result there. We have exactly that result there. So then what exactly then is the question? So now we got this, but if you look at this has given us the answer we need. It has given us the answer we need because we needed the answer to question 4. And the answer actually given is exactly 8 units. And so we went on this side to complete the arc length because we just had to now integrate. And we performed the integral there. So using the half angle formulas, we're able to find the integral. How did we do the integral? How did we do the integral? Right, so we have exactly the following. Right, you have exactly the following. Okay, so we got the answer as exactly 8 units. Now think about it and see where you have questions. Check where you do not understand. Because that is the answer to the arc length of a cycloid. That is the solution to the arc length of a cycloid. And then we will proceed to analyze the next question. Number 5. And then number 5 is going to be done in a similar manner. And so you would proceed to analyze. You'd proceed to analyze that particular question here. You'd proceed to analyze that particular question over there. Right, you would proceed to analyze the next one. Let's check the next question. Okay, number 5 is this one. This is question number 5. Right, if one checks very carefully the question number 5, it is a question that remains very, very interesting. Right. So now you then have to continue. You then have to continue and do number 5. Right, the notion of the length of the asteroid. The length of an asteroid. Right. And the length of the asteroid, the answer is exactly 6 units. The answer is exactly 6 units. So let us analyze this particular question here. Let us analyze this particular question here. Right. Let us analyze this particular question here. Now, to obtain the length of the asteroid, we then have the following. We then have the following. Okay, let's do it. Let's tackle it. Number 5. Okay, now obtain the length of the asteroid. Asteroid parameterized by x equals the cosine cubed of t and y equals the sine cubed of t, where t is between 0 and 2 pi. Here, consider the length of the piece in the first quadrant and multiply your answer by 4. That is, just do one part in one quadrant and then multiply the answer by 4, because these are like congruent or congruent shapes, congruent parts of the asteroid. So let us practice with this. So now our x is cosine cubed t, and our y is the sine cubed of t, dx dt. We need to find the derivatives. So dx dt by their calculus rules is the chain rule. You have 3 cosine squared t, and then we have minus the sine of t. dt, 3 the sine squared of t, and then cosine t. dt. So that dx dt minus 3 cosine squared t, the sine of t, which is 3 sine squared t cosine t. So you're going to have that. You're going to have exactly those derivatives. After those derivatives, then we need to square them. We can just square them before we use the formula. Okay, because we squaring them, we might get some hints from the trigonometric identities. Let's do dx dt squared dy dt squared. So it is negative 3 cosine squared t sine t squared, 3 sine squared t cosine t. Which is dx dt squared plus dy dt squared, which equals 9 cosine to the 4th t sine squared t 9. The sine squared to the sine to the 4th power of t cosine squared t. Okay, now we have this. Can this be simplified? 9 is a common factor, and then we can pull out cosine squared t, so we have 9 cosine squared t and also sine squared t, giving us cosine squared t sine squared t. Cosine squared t plus sine squared t is equal to 1. And this gives us 9 cosine squared t sine squared t, meaning the arc length. It's the integral from a to b of the square root of dx dt, you square it, and then dy dt, you square it. So 0 to 2 pi, so which is 9 cosine squared t sine squared t. Now you find the square root. 2 pi, then you have the square root of 9, which is 3. The modulus is right here. So now the integral, the square root of 9 is 3. Then you'd have the modulus of cosine t sine t. Okay. In line with the fact that let us deal with the first quadrant. So the first quadrant would have to be what? The t in the first quadrant, if t is our parameter, would have to be between 0. So you can do 0 and pi over 2, and then multiply by 4. Let's just do that. Multiply by 4 and do the integral from 0 to pi over 2. Then multiply by 4. If 0 to pi over 2 is going to take a quarter of the interval from 0 to 2 pi. Right. And so if you're doing the integral from 0 to pi over 2 radians dt, and it is therefore for the integral of 0 to pi over 2 radians, the cosine t sine t, the modulus of this, both functions are positive, giving us sine t cosine t dt. Okay. This is the same as what? 2, the integral of 0 to pi over 2 radians, then you have 2 sine t cosine t dt. Okay, so let us continue with what we need to do. The integral, which is 2, 0 to pi over 2 radians. 2 sine t cosine t, which is the sine of 2t. dt. And then we can just integrate this one. Okay, because...
Sorry.
Yes.
Can you please go back?
Okay. We go to this point.
Okay, I got lost where you introduced the 2.
Yes, the 2. Okay, let us deal with that part because we have the 4. The integral from 0 to pi over 2 sine t cosine t. Let us write that one. So you have 4. Yeah.
Where did the 3 go to?
Where did the 3 go to?
Is the one we got from the square root.
From the square root. You're right. So the 3 is going to be part of it. So in essence, let us put the 3 outside. We need it. So we'd need the 3. That came from the square root of 9. Would need the 3. Okay. So Okay, let's see. Okay, the 3/4, then we have the 2, it's okay. And then let us have the 3/4 and everything. Okay, let's have the 3/4. The integral from 0 to pi over 2 radians. The 3/4. The sine t cosine t dt. So which means, therefore, you'd have take out one factor of 2 from the 4. Because the 4 is 2 times 2, then you have 2 sine t cosine t. But 2 sine t cosine t is equal to sine 2t. So here we know that one. And this is a double angle formula. So we have dt. Then you have 60 integral of 0 to pi over 2 radians of the sine of 2t dt. The integral of this becomes the same as what? The integral of sine 2t becomes 1/2 cosine 2t negative. Negative 1/2 cosine 2t. From 0 to pi over 2. 6 times minus 1/2, it's minus 3. Yeah, it's going to be cosine 2t here still. Minus 1/2 cosine of 2t. Meaning this is going to be 2t from 0 to pi over 2 radians minus 3 cosine of 2 pi over 2 the sine of 2 0. And then this is the cosine of pi minus cosine 2 by 0. Good, cosine 2 by 0. So you have cosine 0.
May I ask,
Yes, please.
why are we integrating in the interval of 0 to pi over 2?
Because of the hint they gave to us. Hint, consider the length of the piece in the first quadrant. Consider the length of the piece in the first quadrant and multiply your answer by 4. So the first quadrant is going to be 0 pi over 2 pi 3 pi over 2 radians and then 2 pi. So in the first quadrant, it's 0 to pi over 2 radians. But then we multiply by 4 because you can see there's one piece, one piece, one piece, one piece. But now we did it from 0 to pi over 2, then multiply by 4. But there's a 3 that came out from under the square root. But if you check here, what is cosine pi? Cosine pi is the same as cosine 180, which is minus 1, minus 1. Minus 3 times minus 2. So we have minus 3 times minus 2, which is exactly 6 units. And this gives us the arc length. And which is the answer? The answer is 6 units because we multiplied by 4. So to get the actual length of the asteroid, what do? We consider the arc length in the first quadrant and then just multiply by 4. Okay, so that is something that we've done. And it is something Very easy. So, any question? So, you need to think about what we need to do next. You need to think about what we need to do next. We need to think about what we need to do next. Okay, so we've done number 5. Let us check number 6. Let us check number 6. Let us check number 6. Right. Okay, now we continue. We continue because we've found the length of the asteroid. And to find the length of the asteroid, we use the arc length formula. We multiplied everything by 4 for the 4 parts in the 4 arms of the Cartesian coordinate system. And as we've done that, we actually therefore were in a position to right. So we continue with the next thing. So we continue. Right, so we continue. We continue. Let's look at number 6. Let us look at number 6. Right. Let us look at number 6. Let us look at number 6. Okay, yeah, we're looking at the next one. Okay, now you need to deal with the polar coordinates. Find the rectangular coordinates of the points whose polar coordinates are given. So the polar coordinates are such that they give us the r theta. R theta would be minus 8 pi over 4. But we know that x is r cosine theta. X is r cosine theta. Y is r sine theta. So x becomes the r, which is minus 8 cosine of theta, which is pi over 4. Y is r, which is minus 8 from this. So we have r is minus 8, and then theta is pi over 4 radians. So you have the sine of,
Hello?
yes, please.
Yes, can you please explain why have we selected rather the r cos theta? Like x is equals to r cos theta. Is it always like that?
Yes,
Is it
always like
always the
that.
case?
Always, always. Okay, it's a formula that connects the r theta to x. And the formula that connects the r theta to y is this one. So these are like formulas that allow us to convert from rectangular coordinates to polar coordinates. So that you have minus 8. What is the cosine of pi over 4? All right, it is actually the square root of 2 out of 2. And the sine of pi over 4 is the square root of 2 out of 2. Which is minus 4 the square root of 2. And then this is minus 4 the square root of 2. So we've got x and the y, which is what they've got. So which means the xy, the x is minus 4 the square root of 2, minus 4 the square root of 2. So that becomes the conversion from the polar coordinates to rectangular coordinates. From polar coordinates to rectangular coordinates. So now let us look at the next question, perhaps the Roman figure 2. Right, so we're gonna look at Roman figure 2 because this one we've solved. The answer, it was way too easy, but we always use x equals r cosine theta and y equals r sine theta to convert from the rectangular coordinate system to the polar coordinate system and vice versa. So to convert from the polar coordinate system, we use those formulas there, always. Right, so if we're looking at the next question, we would actually then be thinking about exactly the following. Exactly the following. Right, exactly the following. Right, we'll be doing exactly the following. Right. So we're good. We are so good. We are so good. We solved this one in a great deal of detail. In a great deal of detail. In a great deal of detail. Right. Let's move on to the next question. Okay, yeah. Gonna look at the second Roman figure. Let's look at the second Roman figure. So at this point, we have x r cosine theta r sine theta, which is 6 cosine minus pi over 6. which is 6, the sine of minus pi over 6. Which is this one is the same as the cosine of pi over 6. And this one, the negative goes out, making it minus 6, the sine of pi over 6. But pi over 6, then pi out of 3. 2 square root of 3, 1. Cosine is what? SOHCAHTOA. The cosine becomes adjacent of hypotenuse. Okay, adjacent of hypotenuse would be, if you look at adjacent pi over 6, square root of 3 out of 2. 2 divides, giving us 3 the square root of 3 minus 6, the sine of pi over 6, opposite of hypotenuse, which is 1/2. Opposite pi over 6 is 1, the hypotenuse is 2. And half of minus 6 is minus 3, which means xy, which is 3 the square root of 3 minus 3.
Sorry,
Okay. Yes, please.
where did the negative go to for the
The
6
cosine.
goes? Yes.
Yeah, the reason the cosine is an even function. So cosine of negative theta is always cosine theta. It's the same thing. So whether it's negative or not, it becomes just positive for the cosine. But for the sine of minus theta is minus sine theta. So because of this, the cosine is even, and the sine is odd. It's an odd function because of that property. It's an odd function because of that property. Right. So now we continue to try the third one, the third Roman figure. Which is r cosine theta or sine theta. R is minus 2, cosine minus 2 pi over 3. The sine of minus 2 pi over 3. It's the same thing here. Is minus 2 cosine of 2 pi over 3 minus 2, but it's going to be a minus 1 that's going to come out of the sine of 2 pi over 3. 2 pi over 3 is like pi over 3 times 2. 60 degrees times 2. What is the sine of 60 degrees in this? This puts 2 pi over 3 in this quadrant. And the 2 pi over 3 is 120 degrees, and it leaves us with pi over 3 here. Okay, at the rate at which we have the things here, we have pi over 6, pi over 3. 2, the square root of 3, 1. Okay. Pi over 3 here is going to be pi over 3. Obviously, the square root of 3 here, pi over 690. Right. So now And then we have the cosine of this. And now then, right. Continue. So now at this point, you have the cosine of 2 pi over 3. So check it out and check the diagram. So it is going to come from this. But if this is actually exactly this triangle that has been put there, so this is going to be 2 and this is 1 negative. So right now the cosine of this is going to be, for example, the cosine of 2 pi over 3, which is this one, which is going to be adjacent of hypotenuse in the view of SOHCAHTOA. Right, SOHCAHTOA. So that now the cosine is adjacent of hypotenuse, which is minus 1/2, and the result is 1. Okay, obviously, if you multiply minus 2 and minus 1, you get a 2. The sign of this, therefore, becomes opposite over opposite of hypotenuse, which is the square root of 3 out of 2. The 2 cancels, giving us the square root of 3. So, which means the xy is the same as the x is 1, and the y becomes the square root of 3, which is exactly that. Which is exactly what is there. And that is what we can realize. And that is what we've found. That is what we've got. So I think we shall leave Roman figure 5 as a little. Let us try Roman figure 4. Let's just try. Let's just practice. Yeah, just practice with the fourth Roman figure. At this rate, we look at the fourth one. This. The answers are already there, so we're just practicing. So x equals r cosine theta, y equals r sine theta. The x, the r is, because you're dealing with 7 r theta, 17 pi of 6. So now the r is 7, and then we have cosine of 17 pi of 6. Y, the r is 7, and then we have this sine of 17 pi out of 6 radians. And what is this? What is the cosine of 17 pi out of 6? What is the cosine of 17 pi out of 6? Okay, now 17 pi out of 6 is just short of 1 pi out of 6. So pi out of 6 is like 30 degrees, and it's 30, 60, 90. 30, 60, 90. Degrees, degrees, degrees. So now we're going to do pi out of 6, 2 pi out of 6, 3 pi out of 6, 4 pi out of 6, 5 pi out of 6, 6 pi out of 6, 7 pi out of 6, 8 pi out of 6, 9 pi out of 6, 10 pi out of 6, 11 pi out of 6, 12 pi out of 6, 13 pi out of 6, 14 pi out of 6, 15 pi out of 6, 16 pi out of 6, 17 pi out of 6. 17 pi out of 6. So that You have this sitting here. But if this is pi out of 6, then you're back to then saying, okay, this gives us a pi out of 6. You have 2 the square root of 3 pi out of 6 pi out of 3. Okay. Right, so now at this point, what is the cosine of this 17 pi out of 6, which is here? So the cosine of 17 pi out of 6, then it's going to come here as you put the pi out of 6. So if this is pi out of 6, opposite pi out of 6 is what? Opposite pi out of 6 is 1. And then this one is going to be pi out of 3. And then negative the square root of 3. 2. So that the cosine of this is what? Is exactly SOHCAHTOA. The cosine is adjacent of hypotenuse. Okay, and then you have 17. Then the sine is opposite of hypotenuse. Which is minus 7 the square root of 3 out of 2. So that when you have xy, 3 out of 2, 7 out of 2. Okay, which is exactly this answer here. Any question on how we converted from the polar coordinates to the rectangular coordinates? So any question there? So think about it and make sure you understand what's happening. Right, it is just 6 a.m. and I think that we need to take a break, and yeah, we can you can then let us know if you have further questions. So we shall take a break, but also, I mean, during the day, you can communicate your free times. Yeah, we're going to be having some available time slots today, so we can solve a couple of problems, etc., etc. You can solve a couple of problems, etc., etc. Yeah, right. From us, right now, it was awesome having our discussion here. Until the next time when you're available, yeah, just awesome. Take care. Enjoy the day. We're sending the recording in the next couple of minutes. But thank you so much for joining us, and very, very goodbye to you.
Sir,
Yes, please.
why don't we just somewhere do B?
Which one? 6B.
B. Yes.
Okay, let me check. Okay, I thought maybe also you have a class, maybe. That was my fear. Let us check part B. All right, so now let us read B. Polar coordinates. So in each part, a point is given in rectangular coordinates. Obtain 2 pairs of polar coordinates for the point, one pair satisfying R positive between 0 and 2 pi radians, and a second satisfying R positive in the range of negative angles. Okay, good. Right, we can spend some time on this if you have some time at your disposal. My fear was you possibly would have a class this morning or something like that to attend. But if you look at number one, you're already given in each part, a point is given in rectangular coordinates. So if you look at 6b first Roman figure, you have been given in rectangular coordinates, and these are x and y. So x and y given in rectangular coordinates, where is that point? That point is somewhere here. Yeah. You have 1, 1. Right. So now if x is 1 and y is 1, so this one is going to be the square root of 2, and then you just need to find the angle there. So to find the angle, use the tangent, which is y over x always. Y is 1, x is 1, which means the tan of theta is 1, and therefore you need to get the answer to this. So the 1 out of 1 is seen from the triangle. Square root of 2, 1, 1. Pi over 4, pi over 4. Okay, if you do 1 over 1, 1 over 1, like opposite over adjacent, is pi over 4 radians. That is pi over 4 radians. So now you need to find the first answer, so which means that you have, in the case where you are measuring the angles like this, and these angles are positive. So you would have, therefore, the r theta coordinate system, and the r is this one by Pythagoras theorem, because r becomes always, the formula for r is the square root of x squared plus y squared, which means you have the square root of 1 squared plus 1 squared, and therefore it is the square root of 2. So then you'd have r is the square root of 2, and then the theta is pi over 4 radians. So that gives us the answer. So that gives us the answer. Next, we have found the r and the theta. But now it's not the only way to do it. Obviously, the other thing they're giving us when the angle is negative. So which means that you're going to still look at this and then say you position it here, 1, 1. 1, 1. This is the angle theta, y and x. So r becomes the square root of x squared plus y squared. One squared plus 1 squared, and this is the same as the square root of 2. Okay. And at this point, you find your r, okay, but you need to find the negative angle. Yes, most of the time the angles are special. But if not, then in particular, because you don't use calculators in this module, so the angles will have to be special angles. And then now you'd have to measure, in this case, you'd have to measure the negative angle between minus pi over 2 and minus 2 pi and 0. So Okay, yeah, so you're gonna have that. But if you check, you'd have the angle theta. So that at this point, what would the angle theta be? Okay, you have already seen that this angle is pi over 4 because we use the fact that the tan of theta is exactly y over x. Okay, so x is 1, y is 1. So you're gonna have 1 out of 1, which is 1. So that then you'd have the answer. The answer. So you'd have, therefore, that you can be able to find the angle theta that is wanted. But the angle theta that is wanted at this point would have to be the overall angle is minus 2 pi, but you remove this little bit. So the angle theta will therefore be minus 2 pi, but you add pi over 4. So this is going to be minus 8 pi plus pi over 4, and this gives us minus 7 pi over 4 radians, which is this. By Pythagoras' theorem, we have found the radius, which is the square root of 2 units, and the angle theta is minus pi over 4, because this overall angle becomes minus 2 pi if you go minus 2 pi. Going clockwise. Going clockwise. So we continue. So we continue. So we continue. We're looking then at the next question. Let's look at the second Roman figure. Right, so in the second Roman figure case, you'd have this one. So you've been given x and y because they said in each part, the point is given in rectangular coordinates. And that gives us x and y, 2 to the square root of 3 minus 2. 2 to the square root of 3, and then y is minus 2. Um, so when x is 2 and y is negative, so that's going to be here. X becomes 2 to the square root of 3 and y is negative 2. So Right. Let us check. At this point, you need to find the polar, but you need to find the positive angle. So you need to find this one. But first, what is this angle there? So we have two angles to get. So if you have the tan of theta is y over x, what is this? What is this? All right. 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 Um, okay, continue. Right. Okay, so, and then we have the y. Um, right. 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 Okay. Okay, yeah. So what is our y? 2 to the square root of 3, which is minus 1 over the square root of 3. So if you use the special triangles, this is 2 pi out of 3 pi out of 6 square root of 3, 1. Okay. And so um then you have SOHCAHTOA. If then we're looking at this and we're then saying it is 1 over the square root of 3, of course it is negative. But opposite 1 over the square root of 3, then what is the angle? 1 over the square root of 3 is opposite pi over 6. But because it is negative, then theta becomes minus pi over 6 radians. So there are two angles, minus pi over 6 radians. But you then have to Right. Right. Um, right. Okay, sorry, yeah. This one is minus pi on 6. And there's this other one that is 2 pi. Right. Which is 2 pi minus pi on 6. Which is exactly 2 pi that, which is 12 pi minus pi out of 6, which is 11 pi on 6. So which is are the two angles. So this angle that is measured counterclockwise here is 11 pi out of 6. But by what you call Pythagoras theorem, x becomes the square root. R becomes the square root of x squared plus y squared. Right. To the square root of 3. And then 4 by 3, 12 plus 4, 16. And then that is 4. Right, so there are two possible answers then to this. The first answer is going to be r theta, which is, what is the r? The r is exactly 4. Okay, so the r is 4. So you put a 4 here. And then the theta becomes what? The theta becomes minus pi out of 6. The r becomes 4. R is 4, but there is another angle that is negative. Okay, which is minus pi out of 6. But now there's a positive angle, which is 11 pi out of 6. So those are the two angles. So you have the 4, 11 pi out of 6, and also the 4 and minus pi out of 6 as well. Okay. So now then we've solved the other one on the polar coordinates. And now we'll continue to check the next one. Continue to check the next one. Okay, let us look at like the third one. This. So you'd have the rectangular coordinates system. Right, so that in the end, then you have r x squared plus y squared. The x is minus 8 squared. Minus 8 squared. 64 plus 64. Which is 2 times 64. Then the square root of 64 is, you do the square root of 2, square root of 64. Square root of 64 is exactly what? Is exactly 8 is the square root of 2. Okay, so we have found this. But positioning everything here, you have that the point is somewhere here, where x is -8 and also y is -8. So you have 8 to the square root of 2 -8 -8. You have this. And you have that. So at this point, if then have this, you actually obviously so now you have this, then what is then the angle here? We can get this, or we use the tangent. So the tangent of theta becomes y over x. Y is -8, x is -8, which means it is 1. I started with this is some pi over 4 angle, but you would have x and that being exactly 1, so it's pi over 4. The angle here is pi over 4. But you need to think very carefully, because it's going to be, so the angle theta is going to be pi over 4 plus pi, this one, which is 5 pi over 4. Okay, so, but we have another angle, which is, this is the positive one, so it's pi and then pi over 4. And then we're going to look at this one, which is the minus pi radians plus pi over 4, which is minus 4 pi plus pi is minus 3 pi over 4 radians, meaning that in the third Roman figure, you'd have the r theta. The r becomes 8 to the square root of 2. And then theta is the first one is 5 pi over 4. And then r theta, you have 8 to the square root of 2 minus 3 pi over 4. So which is 5 pi over 4. Five pi over 4. So this would be sort of a pi over 4 angle, but the pi over 4 angle is sort of a reference angle. But the actual angle should be, because the point is sitting somewhere here, it's there. So now you have to say pi, because this angle is pi here, 0, pi over 2 radians, pi, 3 pi over 2 radians and 2 pi. So you then have to then say pi plus pi over 4 radians, giving us 5 pi over 4 radians. Now you have the other one, which is this. So it's 1 minus pi plus pi over 4, which is minus 3 pi over 4. Right. Right, so we continue. We continue. Okay, now we have the last one for 6b, under 6b. So let's check it. So this one, where is this? X is negative and Y is positive. So it's then going to be sitting somewhere here. X is negative and Y is positive. And Y is positive. So now at this point, okay, you'd have this. Let us analyze the angles that are involved here. So at this point here, you'd have like this is associated with the square root of 3. If the y is associated with the square root of 3, what angle is this? So you need to look at the special angles and the special triangles. And then you have pi out of 3 and then pi out of 6. Okay. Square root of 2. So now, I mean, it is exactly, that's not what I mean here. What we're saying here is that it's going to be 2 and the other ratios. It's going to be exactly 2, then this one is square root of 3, and then this is a 1. So that at this point, you'd have exactly the following. You'd have exactly the following. Okay. So opposite the square root of 3 is pi out of 3. So this y is associated with 3. The square root of 3, the angle is pi out of 3. So this is 2 pi out of 3. Right, so that is x squared plus y squared. X is 3, the square root of 3 squared, then minus the square root of 3 squared. So it is 9 by 3. 27 plus 9 is what? It's a 36. Square root of 36 becomes exactly what? Becomes 6. That is going to give us 6 there. So there are two, therefore, possible angles we can sort of determine. 2 pi over 3, that. And then this angle here is going to be, actually, the other angle is going to be minus pi minus pi out of 3, which is minus 4 pi out of 3. Two possible angles can be written here out of this. R theta. The R 6. The theta is minus 4 pi out of 3. R theta. The R is 6. Minus 4 pi out of 3 and then 2 pi out of 3. Okay, so we have the minus 4 pi out of 3 and also the 2 pi out of 3 as well. But now the angle theta can be obtained, or the associated reference angle is obtained by using the y over x formula, where in the fourth question, this is x and that is y. So the y is 3 the square root of 3. The x is minus square root of 3, which is minus the square root of 3. If the tangent is this, so we can look at things like minus square root of 3 over 1. So the associated angle is like pi over 3 reference angle, pi over 3 reference angle. And then if you have pi over 3 reference angle, that's why you have the pi over 3. But then you need to then say, okay, if this pi over 3, then this one is like 60 degrees, then you need 120 more. If it's pi over 3, then you know this is pi. So it's pi over 3, then you can just take pi minus pi over 3, which is 2 pi over 3. Right, so that's what we have. That is what we have. That is what we have. So these are the two answers. Any question on these two answers? And then we have done 6b. And then we are done with 6b. Okay, we have just finished 6b. In the case where the angles are positive between 0 and 2 pi radians, but also the negative angles between minus 2 pi and 0. We must thank you for joining us. It was awesome having this discussion until when you're free again during the day, you will let us know. When you're free during the day, and then we can make use of times, unlike last time. So we'll have ample time today, so we can try some questions just to make sure we practice more, and we can be able to prepare for the coming test when there's still time. Okay, because the test is going to contain these things, so there's no reason, obviously, not to prepare very well for it. With the amount of time we have in our hands, we can actually make sure that we shine the brightest during this test, making sure that we get the most marks. Our wish is to get 100%, because we've had students getting 100% before. So it's not, the 100% is not a pipe dream. It's a reality. It can be achieved because we've had students achieving that. And this one cannot be different. We can achieve that 100%. So we just need to make sure we prepare early, and then we can see where the challenges are, where mistakes are, and then we can rectify them. But yeah, that is what is on the horizon. That is the plan to get 100%. It's the plan. Right. Thank you so much for joining us. It was awesome having this discussion. Until we hear from you during the day about your free time, or otherwise, then we're going to do after hours. If you are busy during the day, it's okay. Then we can do after hours. Yeah, we'll discuss the after hours time. We can make it either 8 o'clock or 10. We'll discuss it. All right.